Hello everyone. Welcome back to my YouTube channel Better Call Paul. My name is Vivek Kaur and we are in the machine learning algorithms playlist. In the first video we have seen about decision trees, how decision trees works, what is the math behind decision tree, what is the statistics behind decision tree, how the nodes get splits, how decision tree algorithm decides which node to split, what is information gain, what is entropy. We have seen the formula for entropy, how it comes. We have seen the formula for information gain, and we applied this statistical formula and mathematical formula onto our original data set, our child data sets, and we have seen on pen and paper basis so that you can understand clearly. Likewise, I will also explain you the same for random forest. Random forest is the next upgraded version of our decision tree. There are some disadvantages for decision tree. Whenever your data set is too large, whenever your data set is too noisy, then decision tree fails. Decision tree leads to overfitting problems. I will explain you each and every step why we should use random forest ahead of decision trees if we have a larger data set in detail. So let's move forward. I will explain you on a notepad. So this was our decision tree actually, and we have trained our decision tree. Decision trees algorithm has entropy and information gain. Uh, Entropy is a more faster and robust way to calculate the degree of disorder, to calculate the degree of randomness. But in scikit-learn, we use Gini impurity. Gini impurity is almost similar to entropy, but in Gini impurity, the formula is different. The formula is the square of your probability. And in information, in entropy, the formula is different. It is probability multiplied by log to the base 2 of probability. But both gives almost same answers. Entropy is taking too much time, whereas Gini impurity is taking less time. So to make the process faster, in scikit-learn library, we use Gini impurity and all the process is same. So now we have seen the decision tree, how it works. So if any kind of test data comes and we use that decision tree to predict whether to give, to take a decision whether to approve loan for that customer or not, we will see if his income is high. If it is high, then we definitely give him loan. If the income is low, then definitely we will not give him the loan. These are the decisions taken by this decision tree. If the income is medium, then we will check his credit score, whether it is good or whether it is bad. If it is good, then we will give him loan. If it is bad, then we will not give him loan. So this is our decision tree. Now our decision tree is formed, it is trained, and it is performing well on your test data. But that is not sufficient. If we have a more number of columns, if we have a more number of data set, then that decision becomes difficult. So it is very difficult to rely on one decision tree only because it gives us good results on a training data set, but it gives poor results on test data sets. So to avoid this overfitting problem, we use random forest. What is actually random forest is, for example, in decision tree, we are asking one credit officer whether to give loan to that customer or not. And in random forest, we are asking to 10 different credit officers whether to give loan to that particular customer or not. So that is the difference between decision tree and random forest. In random forest, we take the opinion of all decision trees, for example, all 10 credit officers, whether to give loan to that particular customer or not. Yes, no, yes, no, yes, no. It is a classification problem, so we will get only two categorical outcomes, either it is yes or no, and we will take the mode of the entire outputs, means we will count the majority votes. If moved number is belongs to yes, then that random forest output will be yes. If moved number will be no, then the random forest output will be no. Likewise, our random forest works. If a random forest is in regression mode, then we will take mean, median, any kind of value. We will take the mean of the outcome, or we will take median of that outcome. Likewise, we get the output from our random forest. Now we will see how it works on pen and paper basis. Okay, so I will just draw. So random forest. Now I will draw a simple example because for random forest we have to use a larger data set. But to explain what is random forest on a tree like diagram, I will just explain you the structure so that you can understand it quickly. So, for example, this is our basket, and here are so many mails. I will explain you. There might be some spam mails, or there might be some uh, ham mails. Ham mails means those who are not spam mails. I will use these. These are mails, emails, you can say. Now, this is our data set. For example, it is of 300 mails. So, green means it is ham, means genuine mail. And red means it is spam. Okay. Now, let's say we have created three random trees, three decision trees. So here we have created three decision trees, and here the most important thing is we have used Bootstrap random sampling. What is meant by Bootstrap random sampling? We have 300 mail into our original data set. We are picking 100 email in one data set, 100 email in another data set, and 100 email in another data set. Now we are randomly picking 100 emails from our parent data set, and then again we are putting these 100 emails onto original data set, then again picking 100 emails from that original data set in the second decision tree. Likewise, we again put these 100 emails into our original data set, then again picking 100 emails for the third decision tree. Now, what is the possibility by doing this bootstrap random sampling is that there is a high possibility that same rows or same data will be appear in the second decision tree, or there might be possibility that uh, same rows are appear in our third uh, decision trees data set, child data set. And also there is another possibility that many of the rows are unseen in all the three data sets. So these are the possibilities, and this is the actual concept behind this bootstrap random sampling. Now, in this 100 child data set, we have a decision tree like this. There will be one node. After that, for example, it is income. Then there is a income high, low. Then Miss, I'm taking example of the previous one. Now this is mails. There are many columns like sender, receiver, attachment yes or no, some words, lottery or bonus, present in or not. Uh, there is a might be frequency, there might be time. A lot of columns are there. So I'm just taking example of these. data set, our previous data set, income, credit score, age, employment, and loan approved is the final. So this is income. Now income high, low, and medium, whatever it is. Then another is your if it is high, then check credit score high, low. Then there will be another data set. Maybe age is high, low, young, or whatever it is. So this will be our decision tree, and the same applicable for your another tree as well. I will just copy it. Control C, Control V. Uh, okay, Control C, Control V, and here we can increase slightly. Okay, these are our decision trees, and maybe one decision tree based on his data is giving us decisions like this. I will explain you. Hmm. Yes. So it might be giving us decision like this. So follow this track, and this is giving a decision like this. This one is giving decision like this. So they are identifying if income is high, then check credit score. Credit score is good, then check or if email is spam or not, like that. And finally, the conclusion becomes like it is a spam. It is spam. Spam means no spam. This is spam. Okay, and means what we did right now, we have provided the same data. For example, in this case, we have provided the same email to these three decision trees, and we ask these decision trees to predict whether that email is spam or ham. One decision tree, first decision tree tell us this is spam. Second decision tree tell us this is ham. Third decision tree is telling us this is ham. So this is spam. And now how this we have seen that Bootstrap sampling is completed, training is completed. Also, we have provided the test sample, and we check the decisions of all the decision trees. Now bagging comes into picture. We accumulate the decisions of all the decision trees, and we are approaching to our final answers. Now we are using mode method, a statistical method. Mode means uh, those who are more number of outputs, means either it is yes, 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 and lower is no, no, then the answer is yes. If more numbers are no and less numbers are yes, then the answer is no, means the mode is no. Mode means basically uh, what is the maximum frequency of that particular categorical value. Here I will mention one second. One email sent to each decision tree, and everyone is giving answer. Okay. Now decision tree one is giving us answer spam. Second is giving ham. Third is giving spam. So the mode is the maximum frequency. Maximum frequency is telling us that this particular email, whatever it is saying to the particular decision tree, are spam. So our random forest will decide that that particular mail is spam. So this avoids our overfitting problem. This avoids our noisy data problem. Means this is just an average. This is a generalized answer, so that our accuracy is highest on non-trained data, on test data. This is how we increase the accuracy of our model by choosing a random forest model over diffusion trees model. So this is the basic concept behind this random forest. We are just averaging. We are just means this is classification, so we are not averaging. We are taking more. If it is regression type, means for example, if the income is 12 lakh per annum and the house price is 45 lakh rupees, then whether that customer is going to buy the house or not. So the salary package is the numerical value. It is continuous value. It is regression value. So in that case, we will take mean median. But in classification data set, we will take classification output data column. In the data set, we will take mode of that particular decision trees, and we will predict whether that particular email is spam or not, whether it is yes or no, whether it is true or false, whether it is north, southwest, or and so on. So this is a means the random forest is basically a forest of so many decision trees, so many trees. So that's it. So in today's video, we have learned about random forest, how random forest works, what is the math behind a random forest, what is the statistics behind random forest, and there are a lot of disadvantages of using random forest. For example, a random forest is giving us a generalized answer. Means it is just averaging the decision trees output. It is just taking mode of the output of the decision trees. But that is not the correct way. If you want to increase accuracy even more, then what we use? We use boosting techniques. What are boosting techniques? XGBoost is there, ADA boost is there, Kata boost is there. There are so many types of boosting techniques are there. Advanced techniques, modern techniques, modern algorithms are there. So we will see these modern algorithms, XGBoost, Kata boost, ADA boost, in the upcoming videos of this playlist. So stay tuned with me. Please like, share, and subscribe to my channel to get the theoretical and practical understanding of the concepts behind these data science projects, behind these data science, machine learning, deep learning algorithms. Thank you very much.